Okay, in this lesson we're going to continue using the trigonometric form of complex numbers, and to review we have 1 plus 2i. We had this in the previous lesson, and we can write it in trig form. If we graph that and found the radius, it would be radical 5. And if we did inverse tangent of 2 over 1, we'd get 1.107 radians, and we can write it like this. Something else we could review is we can have a complex number to a power. In this case, we would have to distribute, and we'd get this. We could simplify it to that. But if we had this, well, we wouldn't want to use distribution to calculate that. So we have this formula called de Moivres formula, and it's going to use trig form of a complex number to easily evaluate powers of complex numbers. So if we had 1 plus 2i to the 10th, we would just use the trig form, which is that. We would have radical 5 and then we'll raise that to the 10th power. Those are equal. But with de Moivre's formula, we can just do this. Make the 10 the power of the number in front, and we're going to then multiply each of the angles by 10. Make this the power of that, and we're going to then multiply each of the angles by 10. This is 5 to the 1/2. 1/2 times 10, so it's 5 to the 5th. If we evaluate cosine of 11.07 radians, I have a 1 here, so I'm just going to put the 1 there. And this will be 3,125. Cosine of this is 0.075. Sine of this is 0.878. Then we can distribute this to each of those, and we were able to evaluate the power of a complex number without doing a lot of distribution. So that was using de Moivre's formula, and here it is. A complex number to the nth power is going to be just like we just did. We can use it for powers of a complex number, but we can also use it for products of complex numbers. And if we had a cosine theta plus I sine theta times b cosine beta plus I sine beta, we can multiply a times b, and then we can add the angles, theta plus beta, cosine theta plus beta. Alright, so those are two ways we can use the Moivres formula. Find each product. This is a 4. Or we'll just say find the product. So we get to multiply 6 times 4. And then we're going to go pi over 2 plus pi over 4. We can evaluate at 3 pi over 4. So cosine is negative 1 over radical 2. Sine is 1 over radical 2. And we distribute the 24, and we'll get 24 over 2 is negative 12. 24 over 2, we have 12 radical 2i. Alright, pause the video and try that one. 2 times 3, pi over 6 plus pi over 2. And we could write pi over 6 plus 3 pi over 6. So pi over 2 could be 3 pi over 6, and we go 3 plus 1. We have 4 pi over 6. And 4 pi over 6, if we looked at the sixths, we have 1, 2, 3, 4. And cosine is negative 1 over radical 3. Sorry, negative 1 over 2. And sine is radical 3 over 2. Then we can multiply by 6. 6 times a half. 6 divided by 2 again, and that's going to be 3 radical 3i. And we can use it for division also. Here we'll just divide coefficients, and we will subtract the angles. Three divided by a half, and also 3/4 minus pi. If we have 3 pi over 4 minus, pi is going to be 4 pi over 4, and that gives us negative pi over 4. So 3 divided by a half is 6. Cosine, this is going to be negative pi over 4. And we'll look at negative pi over 4 is there. So the cosine is 1 over radical 2. The sine is negative 1 over radical 2. So we have 6 radical 2 over 2, negative radical 2 over 2. And that will give us 3 radical 2. 6 times that will be negative 3 radical 2 times I. All right. Express in rectangular form. Well, this one, we're just going to use de Moivre's formula and then evaluate each trig function. But over here, we don't want to do the 6th power in this form. We need to convert this into trig form. Then we can use de Moivre's formula. So let's look for the radius, and that would be when we find the absolute value. So it's going to be 2 plus 2 radical 3. We don't include the I when we do this. 4 plus 4 times 3. Square each of them, and that's going to be 16. We get a 4. And then to find theta, we go inverse tangent of the vertical over the horizontal, and that gives us 60 degrees. So now we have this is the same as 4 cosine 60 plus I sine 60 degrees, and then we want to raise it to the 6th power. Now we use de Moivre's formula. 4 to the 6th cosine 6 times 60 is 360. So we have this as an exponent of 4, and then we multiply 60 times 6, and we get 360. 4 to the 6th power is 4096. Cosine of 360 is 1. Sine of 360 is 0. So the answer is 4096. All right. This is going to be done the same way. We just don't have to do that first step. We start from here. So pause the video and try that one. We have 4 to the 3rd power cosine 3 pi over 2 plus I sine 3 pi over 2, and 4 to the third power, 64. Cosine of 3 pi over 2, 3 pi over 2 is down there, and that means cosine is 0. Sine is negative 1, so we have negative 64i. Okay, we can also find roots of complex numbers. We could just think of that as a fractional power. That's what it is. So now we've done powers of complex numbers. Let's find the if there's you're doing a fifth root, then there's 5 fifth roots. If you're doing a fourth root, then there's 4 fourth roots. So this de Moivre's formula allows us to find all those roots. Alright, so if you have whatever complex number you have, it'll help to write it in standard form. So the fifth root of 0 plus negative I. This will allow us to find the radius, which would be 0 plus negative 1, and also to find theta, which is going to be inverse tangent of negative 1 over 0, and that means we get negative 90. Inverse tangent negative 1 over 0, we need to know what angle has a y of negative 1 and an x of 0. Y of negative 1, x of 0, and we're looking at negative 90. We can't do that on the calculator. We'll have to do it by hand. So we can write this in trig form. We have 1 cosine negative 90 to the 1/5 power. The 1/5 does apply to the 1, but it won't change anything. All right. So we know that we're going to multiply the angles by 1/5, and that will give us a starting angle. We also know that the, well, we don't know yet. I'm going to tell you that the angles are evenly spaced around the circle, and we're going to have 5 evenly spaced angles. So if you have in a circle 360 degrees and you divide it by 5, then we know that 72 degrees separates each angle for each complex number. So now we're going to look at, we'll have 1 to the 1/5 cosine negative 90 over 5, because we're multiplying this by 1/5. So we have root number 1. That will be it. That equals negative 18. So we have cosine negative 18 degrees, I sine negative 18 degrees, and that equals 0.951 minus 0.309i. We're just going to evaluate that with a calculator. So that's a standard form of the first root. Then, since we know that the complex numbers are spaced by 72 degrees, we're just going to add 72 to this, and we have, if we did that in the calculator, 0.588 plus 0.809 I. Let's go with negative 18. We already added 72. We're going to add another 72, and that would be 144. And we do that in the calculator, and we get negative 0.588 So we've added 144. Now we're going to add another 72 to that, and that gives us 216. Root number 4 is negative 0.951, negative 0.309 I. So we've already added 216. We have to add another 72 to that. So that's going to be 288. And that gives us 0 minus I. So to review, why are we using all these numbers? Well, we know that they're, because we have 5 evenly spaced angles, we're going to go 360 divided by 5 is 72. That means to get each next angle, we add 72. So if we start at negative 18, to get the next angle, we add 72. Then to this, we're going to add 72. So that means we're going with negative 18 plus 144, negative 18 plus 216. Each time it gets bigger by 72, and then we just do that on the calculator. And don't forget, this only had a 1 as a coefficient, so we didn't have to worry about that, but we want to always have a 1. Last example. So here we have a complex number. We want to find the cube roots, and we know that there are 3 of them. So we're going to find the absolute value, and that's going to be and I just remembered earlier in the, go back to this example. I guess that's written correctly. Okay, and so we have the coefficient. Let's find theta. That's going to be inverse tangent of 44 over negative 117. And we get negative 20.609. That's where we'll start. We know that if we go 360 degrees, and we need to have 3 evenly spaced angles, they will be spaced by 120. But one thing we have to consider here, and that is inverse tangent. It's only giving us angles from -90 to 90. But if we look at the graph of this complex number, it's going to be -117, +44. It's over there. So when we have -20.609, we actually, to get started for the first one, we have to go up there, which means add 180 to that. And we're going to have -20.609 plus 180, and that'll take us to 160.609. Alright, so we have 125 cosine. Our first angle will be 160.609 degrees plus I sine. This is all to the 1/3 power. That's the third root. Then we'll put that as the power of 125, and we'll multiply each of these by 1/3. We have 125 to the 1/3, and then cosine 160.609 divided by 3. We're multiplying the angle by 1/3. So that's why we have division by 3. And this is going to be 5. So there's the first root, and we're going to have 2.97 plus I 4.02. Let's put the I after the 4.02. And the second root, we have to add 120 to this. We haven't used the 120 yet. So 5 cosine 53.536 plus 120 . And if we do that on the calculator, we're going to have -4.968 plus 0.565I. Take the original angle, and now we have to add 120 again. That'll be 240. Which with the calculator we would have 1.995 minus, and remember that we are evaluating these, but we're also multiplying by 5, so you have to do the multiplication by 5 to get those answers. And that's the end of the lesson.